Welcome to project number 4 for Fluent for fundies of aerospace. Let's get straight to it. First things first, what we're gonna do is go on to our normal phase. So we're gonna first create our cylinder, then our rectangle, alright. Now what we're gonna do is add some dimensions. So first things first, diameter is gonna be 1 meter. The height of our test section is gonna be 5 meters. The length of our test section is gonna be 15 meters. And now what we want to do is we're going to do another general. What? We're going to do another general. I'm going to click from here to here. Now that our system of interest is set and defined, what next we're going to do is we're going to create a new sketch. We're going to draw a new small rectangle around our cylinder. We're going to dimension that real quick. It's going to be 2 meters. V10 is also going to be 2 meters. And horizontal here to here. It's of course going to be 1. Vertical here to here. It's going to be 1. Alright, now that we got our rectangular nice and center, we're going to also add these lines. We want to make sure they're perfectly vertical and horizontal. Okay, this line right here. Nope, put this line right here. Gotta get a new one. Alright, now that we have those, one is gonna be our last two lines. Now we wanna make sure that these are modify trim. The trim tool, alright, perfect. Now with those set, next things we can do is we're gonna go to tools. First we're gonna do surface from sketches, sketch number 1. We're gonna apply, and then tools, we're gonna generate, then tools, we're gonna do a face split, target faces, we're gonna select the whole face, apply, total geometry. We're gonna come here, we're gonna add the edge selections only, and we're gonna go one by one, adding these. Alright, and now we click apply, and if we look, click generate. Now if we look, our do have to edit this real quick. Forgot to add that. Alright, perfect. I'm gonna click apply now, generate, and then now we should be able to, we should be good. Perfect. Alright. Now this is it for our design part. We should be able to exit this out. Now we're gonna go into our mesh, edit. Once we're in our mesh, we're gonna come here. First things we wanna do is we want to insert a bit of different sizing meshes. We're gonna come here, we're gonna go with our edge selection, we're gonna click all these faces. Alright, apply. We're gonna element size, we're gonna go for number of divisions. Alright, we're gonna edit that real quick. We're gonna do insert sizing. Alright, so geometry, once again, edge select, we're gonna click these, apply, element size, switch to number of divisions, insert sizing, same thing, apply, number of divisions, and we're just gonna keep following this process until we have every single line kinda in that way. Next part is gonna be pretty important. Now we're gonna edit each individual our sizing, and depending on the sizing is gonna tell us or depend on how our results are gonna be or how accurate our results are gonna be. So we're gonna switch this to 40 number of divisions. We want this to have a bias type. What even bias type? Of course, we're gonna put yeah, we'll leave that one like that. Bias factor of 4. Apply, and then reverse bias. We wanna reverse the ones that are not being biased towards the middle. So we're just gonna make sure we're still on edge select. We're gonna click this one, this one. Actually, matter of fact, what we're gonna do is do this, switch it up to this one. Alright. And now the only ones we have to reverse are this one and this one. Apply. Okay, those look good. Alright, moving on to number 2. We're gonna do number of divisions again, 40. Bias type. Click this one. Bias factor of 4 again. And we're gonna reverse this and this. Apply. What? And this one. Alright, that one looks good. Moving on to our third. Number of division is 90. Bias type. Bias factor of 6. What we're gonna do is switch to this and reverse this one. Apply. That one looks good. Alright, we're gonna move on to this one. Number of divisions. We're gonna click 70 for this one. Alright. Bias type. We want it more towards the middle, so we're gonna click this one. Bias factor. We want to do a bias factor of 1.4. I'm gonna do 2 actually. Might as well. Okay. Next. Alright, number of divisions. We got 70 again. Bias type. We want it all in the middle because that's where our main point of interest is gonna be. Bias factor, we're gonna click 2 again. Alright, and last but not least, number of divisions, we're gonna click 30. Bias, we want a boom boom boom, and a bias factor of 8. So let me see which ones are the ones that I have to rotate or reverse. This one and this one. Apply. Okay, great. Now, next thing we want to do is we want to do a face meshing and apply it to all of our faces to create a more uniform face or mesh. We're gonna apply. Alright, and we're gonna click generate. Let's see how this meshing turned out. See, this is how our mesh turned out. Actually pretty nice, if I do say so myself. You know, pretty uniform when it comes around the cylinder, which we like to see. Alright, we're not done here though. What we want is, before doing anything, we're gonna go over and go to edge select. We're gonna go control, 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 and then control. Sorry, I apologize. Alright, we're gonna name this inlet. Alright, we're gonna be naming this symmetry. Symmetry. We're gonna name this outlet. And our cylinder, we're gonna be naming it wall. Alright, so make sure we got inlet, symmetry, outlet, and wall. Perfect. Alright, we should be done with our mesh now. We're gonna click out of this. Update. We're gonna click update. Alright, now next we're gonna go into our setup. Alright, so in here we're gonna be able to do a couple things. First, we want to make sure that our viscous is set to laminar. Right now, I didn't say, but we're testing laminar flow of air for a Reynolds number of 200. So we're gonna make sure this is laminar. Make sure everything else is off. Materials, fluids, air. Let's make sure the air properties are all good. Alright, boundary conditions, inlet. We have to edit the inlet velocity. So velocity to meters per second. So for a corresponding 200 Reynolds number, the air velocity should be in the 0.0029215 meters per second for a cylinder that's 1 meter, that has a 1 meter diameter. Alright, internal, symmetry, outlet. I like to do this for my outlet. Prevent reverse flow, apply, close, symmetry, wall. Want to make sure the stationary wall, no slip condition, apply, close. Alright. Reference, or we want to go to reference value. We want to compute from inlet, make sure that the velocity is all set. And now one last thing before we click run. Right here, we're gonna go to monitors, report plots. We're gonna setup, or I mean, double click. I'm gonna click on new. This is gonna be, the name of this one is gonna be the drag coefficient. We're gonna do right here, force report, drag coefficient on the wall, which is gonna be our cylinder. Force vector, of course, is gonna be the x, because yep, over average operations. Report file. Make sure everything is good. We're going to click OK. Alright, name. We're going to click this. Drag coefficient. Perfect. Alright, Y label. Drag coef. Alright. Yeah, perfect. Alright, we got our drag. Yep. Drag coef. Close. So we're able to do that in here to plot the drag coefficient over the cylinder, or over our whole. Yeah, we just drag our drag coefficient. Yeah. Before we run it, I want to click on initialization. It should be everything good. All right. The initialization is complete, so we go on to run calculations. Time scale, automatic, yep. Of course, number of variations. I'm gonna click 800. 800 should be good. You know, reporting interval, profile, okay. Everything looks good. Alright, we're gonna click calculate. And we're gonna wait for the results. Here it is. Here's a CP distribution along the wall or the cylinder. So as you can clearly see here, we got our maximum pressure, because it's when it first hits it. And then yep, it looks looking good. Next we could do this here is we can graphics, do a little contour, velocity, yep, it's gonna be velocity magnitude, surfaces, yep, interior surface body, smooth. Alright, save and display. So here we have our yep, here is our velocity contour. Now I do this on the other one, which is gonna make it better, which will. Before we go, I want to check real quick. Alright. Okay. Alright. Alright, and here we have our drag coefficient over our cylinder. Alright, so our solutions are done. And we want to click on results. Alright, so first things first is we want to plot our velocity contour. Alright, domains, symmetry. Yeah, symmetry 1, symmetry 1. Here we gotta click symmetry 2, symmetry 2, symmetry 2. We're gonna do velocity, range, global, and 20. Alright, so that is the velocity contour, but we're gonna wanna do the vectors too. Alright, so with this domain, yeah, location, symmetry 2. Velocity factor, yeah, apply. Now here it is with the velocity vectors. I'm gonna take out the contour so you can see it. So here's the vectors. So next thing is we want to do is the pressure pressure, location, symmetry 2, apply. So we want to see that real quick. Here is our pressure contour. And next is we want to add a, I'm pretty sure it's a polyline. Okay. Domains, method, boundary intersection, intersects with wall, and symmetry, yep, wall. Apply. So we have that polyline. So that means that we are able to do the velocity distribution. V. Alright, data series, yep, location, polyline 1, x-axis, we're just gonna do x. Yeah, because it's the velocity distribution over the cylinder, right? So x. Yeah. Variable is gonna be velocity. Y-axis. Line display. Boom, boom, boom. Alright, apply. And what we can see is it makes sense because since we have the no slip condition, the velocity around the surface of the cylinder is going to be 0. And next, yep, that should be all. Once again, here is the pressure, velocity, and the velocity distribution over the surface. In here we have our drag coefficient, and of course we have right here CP or CP distribution along the wall. So thank you for watching.